Hello, I'm going to talk about the BoltOps reference architecture here. We built all this infrastructure already, and now today we're going to deploy some applications onto this infrastructure. This is pretty cool. We're going to deploy both to the production VPC as well as the development VPC, and we're going to deploy a demo application. We're going to start off with the demo backend application. So this video is going to focus on the demo backend application. Oh, I should mention in this video, the infrastructure is built all on one AWS account. So we're taking the single AWS account strategy here. So I'm going to show you how to do that with one AWS account, okay? All right, let's click on Backend app. And down here, basically, there's some instructions to kind of install the app locally and just get the server starting locally so you can test it and get your bearings. Okay, we'll go right through that. And then after that, it talks about creating an ECR repository and basically getting this application onto AWS, okay? And there are links out down here to one account, so you just have to look for one account here, and one account here. So there's a couple places where the commands are different when it's a single account strategy versus a multiple account strategy. And it's all linked in the documentation here, so we'll just follow right through it, okay? So I think with that summary, I think we're ready to get started. So let's get going. Let's grab these install commands. I'm gonna go one level up here, and then I'm just gonna go to clone the repository down, cd into it, and do a bundle. Okay, so we've done that successfully now. Next command, it says just bin web, which is just starting up the web server, and then we're going to test it locally. Let's close that off. Bin web. Okay, so that starts the server up. That's good. That looks kind of good. And let's open up another terminal so we can test this real quickly. So this is the front-end app, so we just curl a local, this is the back-end app. So 8080. And there, it just returns 42. That's all it really does, okay? So that looks good so far. We finished that part. Now we got to create ECR repository. Okay, so with the multi-account strategy, you actually have ECR repositories on different accounts. All right, here with a single account, we just create the same one ECR repository and use that. You can create multiple ECR repositories too, but I'm just gonna create one and just kind of get it done. Okay, so to do that, I'm just gonna grab this command right here. So what I did was I opened up. I right-click and open up this link here to one account create ECR and kind of link me actually directly to the section, but I screwed up just to give you guys some context. Okay, and it basically is a summarized difference of the commands. One is a single account versus a multiple account strategy. So we're doing single account here, so we're just gonna grab this, and it basically says only create one repo. Yeah, because that's all we really need. And close that off, stop the server there, and then run that command. So that creates the ECR repository demo backend. Okay, so that is done. Now we're going to go back to the main README here, and ECS deployment. I'm actually close that down again. Okay, and now it says let's deploy the app to the ECS cluster, and we're using a tool called UFO to do this. It's a tool I wrote that basically makes it pretty easy to get an application onto ECS. It does when you're working with ECS, you got to do three things, and that tool does those exact three things. You got number one, build a Docker image, register ECS template definition. That's basically it tells ECS how to provision and run the container on the EC2 instances. And then lastly, you make an API call to update the ECS service, and then basically you deploy the ECS service, and optionally you create load balancers. This is a backend application, is a web application, so it's going to create a load balancer and all that. And this is all configurable. But yeah, mainly those three steps: build Docker image, register task definition, deploy the ECS service. Okay, so we're going to be using that tool to do this. And this project demo backend already has actually .ufo files are all set up and pretty much kind of pre-configured. All you have to do is adjust some values, and then we're off and running. So it talks about adjusting the values here. So what we just did was we adjusted we created an ECR repo, and now we actually have to adjust the .ufo settings where the repo image is. And it says right here, use the one account. So I'm gonna go ahead and open that up again. It's gonna link directly to the part where we need to adjust it. So right there, adjust settings. There's three steps. Adjust settings to use the same image for development and production, because we're only using one ECR repository. So I'll show you what that looks like right now. Let's go in here, UFO settings.yml. So the top level settings, okay? So here, this is where we need to grab the repository we just created right here. Okay, and then throw it right in here, and we can use the same one right in here. And if you want, I mean, base gets merged into all the other ones, so you can actually simplify and throw it up there, okay? All right, so next step is saying make sure the stack naming has append env. So by default, this project has a multi-account strategy, so we just have to get rid of append nothing here and use append env. So I'm just going to do that. And what that does is when UFO deploys the ECS service, it actually does it via CloudFormation, so it creates a CloudFormation stack. Well, this stack naming basically appends the environment to the end of the stack name. And it does that because we're deploying on the same account. So we don't want the stack names to collide, okay? Or like production development, we don't want those stack names to collide. So this will prevent that from colliding, okay? So let's go back and see what the third step is. Use AWS Profile 1. Okay, yeah, that's a good reminder because right now, see, we have different AWS profiles for multiple accounts and all that, but we just are using one account here, okay? Okay, so that looks pretty good to me. Moving on here, let's go back to the main README, okay? Adjust network setting. So with adjust network settings, there's no special things you have to do here for a single account versus multiple account strategy. So we're just going and adjust it, but essentially you have to go look for the settings, network development YML, and production.yml, okay? So in here, there's a settings folder, and there's a network folder, development, and there's production, okay? So I'm going to put it stack above each other. So we just need basically VPC, ECS, subnets, and ELB subnets. So I'll explain what these things are. So when the UFO tool deploys your application, it needs to know where to deploy it to, like which VPC to deploy it to. So basically, we have a development VPC and we have a production VPC. They're segregated. They're in the same account, but they're segregated. They're separate VPCs for security. So we have to tell UFO that what the VPC values are and what the subnet values are. Now, the ECS subnets are basically where the Docker container is going to be deployed onto. Okay, so we want that to be in private subnets. And then the ELB subnets is basically where the load balancer is going to be deployed to. And here it's saying we want private subnets also because a backend application here, we're just using it as an internal application only. We don't want this to be internet facing at all. So we could basically deploy both the Docker containers as well as the load balancer all in private subnets. Okay, so we're going to go and grab these values. And to do that, we just go to the CloudFormation console and look up the outputs on the on each VPC stack here. So I'm looking at VPC development first. And I'm going to grab the VPC value first. So I'm starting with development. So I'm going up here. Then ECS subnet. So we want private app subnets. There's private app subnets. And I'm just going to grab these values. I'm going to use the same values for both ECS subnets as well as the ALB subnets. Okay, so I'm done with development. So I'm going to close that off. Now I'm going to go to production. VPC production. There's the outputs. Here are the VPC values right there. Just plug that guy in. And now we just need private app subnets right here. Those three. Okay, and we replace this. And that looks good. So we can close that off now. Okay, so let's go back to the README and follow on the next steps here. So we're pretty much done with the network settings. Internal Route 53 record. Okay, so it'd be also very nice and convenient to have not just the dynamic DNS record that's created by the load balancer, but actually have like a pretty internal endpoint to point to the backend application here. So what we're gonna do is we're gonna use the private Route 53 hosted zone to do this. And there's a screenshot here to kind of go creating everything. So I'm just gonna go through the AWS console. Just so you know, there are some documentations in here to show you how to create a Route 53 record in the CLI, but I think it actually is more instructional to do it through the console. So I'm gonna go ahead and go do that now. Okay. So let's go to find, Route 53 is not there, so I'm just actually at that shortcut right now. To the top. Okay, here we go. Now we got Route 53. Okay, so Route 53 is there. And we can go in here, DNS, and we have a, so I guess we already have one, so I'm going to delete this from previously creating it. And I'm going to delete it and just recreate it right now, okay? So delete it. Okay, so you know how it's created. So I'm going to go create hosted zone. And we're going to call it dev.private, okay? And we want a private hosted zone. And then we want this to the development VPC. So let's go find the development VPC right here. Yep, okay, and create. Okay, and then now I'm going to create one more. I'm going to create the production one. So for that one, I don't want to create record set. I want to create hosted zone. So let's go back to the hosted zone. Go create hosted zone and go PRD private, okay? Private hosted zone right here. Now let's scroll down to the production account, okay, and you can go ahead and click create. Now, since these are private hosted zones and they belong to different VPCs, I could actually name this both private, but I kind of prefer to have that distinction at the DNS level. I found that a little easier to kind of just debugging everything. But yeah, if you want, you can use the private. Just make sure that the rest instructions you account for that, okay? or you can use any other name here, okay? So those are all done being created. So that step is now done. And now it says, oh, that step's not completely done yet. So we created the routes here, but then we also have to adjust the CNF files, okay? Because we created a Route 53 record, okay? So now we have to associate, or we have to tell UFO to use that host name to create the DNS record. So that's in this .ufo settings, CFN development, and production file. So let's go open those up and then ingest those. Let's go down here, development, and you scroll down. Oh, that's looking a little bit funny, so I'm just going to refresh my browser. Sometimes Cloud9 does that. Okay, there we go. Now we see the full kind of text file. Okay, now down here in development, it's already there. We just literally have to uncomment out. Now, it does say something about here, internal Route 53 record right here. So let's open that up and saying that with the internal Route 53 record, because earlier in the settings file we used basically append env, the curly bracket stack name here, which is just like a variable substitution that UFO does, kind of, is going to actually have the full demo backend web dash development. The environment name has been tacked on here. Okay, that's a little bit long, especially since we have qualified it here. So we're going to just kind of use an explicit value here. So let's just actually can use this explicit value. Okay, so we don't get the extra development. So that's what those instructions are kind of saying right there. So I'm going to paste this in and remove that. Okay, and we're going to do the same thing for production. Okay, so for production, we go in here, uncomment this out, and of course it's a little bit different in naming, so I'm just going to paste that in and delete. There. So now we're just going to be a little explicit about the name instead of just using that variable substitution here. Oh, I think I uncommented out a little too much here. That's a comment. Let me double check that I did that. Okay. Okay, so that looks good. Yep. Okay, so next step. Okay, so we basically have cloned down the repo. We configure some values, and we configure them with a single account AWS account strategy in mind. Okay, now we just deploy it, and the deploy commands are actually the same. Okay, so we just kind of run these commands to deploy. Let me close this off and then kick off the deploy. So I'm running the first deployment command, and it's starting right now. No wait right there, and then it's pushing up to the ECR registry here. So let me actually explain this UFO commands in case this is your first time seeing it. Okay, so what it does is it builds the Docker image first. It does those 3 steps that is on the cover in the documentation page here. It builds the Docker image. Then it's going to register a task definition, and then it's to deploy it. Okay, deploy it to ECS. So right now here is building Docker image, and then it's going to push up to the registry. That was the in settings YML. That was the image property that we kind of set. It's going to take some time to push, but I'm waiting for the push before I pause the video here. But let's wait for it to push. After it's done pushing, then it's going to actually kick off the CloudFormation stack deployment, which is going to create the ECS service as well as the load balancer, as well as the Route 53 record, and tie it all together. Okay, so should be kind of almost done pushing here because I'm pretty fast connection with Cloud9 here. Okay, just a little bit more, and you can see while it's kind of doing this, it spits out the Docker commands for your convenience, so you kind of know what's going on there. Okay. And this is all covered in the UFO ship site. All the documentation is there to kind of show exactly how this works. And it's just a little bit more, just waiting a little bit more. But I think it'll be good to wait for this part right here. And then we're going to see the CloudFormation stack update. And then after that, I'll pause while this ECS service gets creating all that kind of stuff. All right, I think that is going to be finished just about now. Okay, so that's still pushing. Okay, there, all push. See, so once it pushes, it builds the task definitions right here. So basically generates some task definitions based on some of those .ufo files there, and then registers your task definition, and then it starts to deploy. And I'm going to start now the production deploy, and it's not going to have to do the same thing. Okay, and you know, the pushing the production is actually going to be a lot quicker, because it's using the same ECR repository and it's using the same cache layers there. But anyway, let's actually do a check on this on CloudFormation to see the stacks that were created by UFO. So see, there's 2 stacks created by UFO. It's the name of the application, demo, backend, and then kind of the role web. there, and then the environment that's tacked on in by the append env setting in the settings.yml file. So you can click on here, and then you can see the events kind of here, and it's kind of coming on. And so all the resources are going to take some time to create. So I'm going to go ahead and pause the video now, and so you don't have to wait for this. Okay, so both ECS stacks created by UFO have finished deploying. You can see right here, and we just kind of maybe click here. These stacks are associated with UFO here. They're one for development, one for production. We can see how long it took by clicking on events here. Scrolling down the bottom. 9:09:47 was when it started, and 51 is when it finished. So it took about 4 or 5 minutes there. To check how this thing is actually, if it was working, let's actually go click on outputs, and you see on the outputs of the UFO stack, it actually spits out both the Route 53 record as well as the ELB DNS endpoint. So you can check by either of them. We're going to grab this one for now. The tricky thing about checking with internal load balancers is you're not going to be able to hit it from the outside world. So I'm on my Cloud9 box. I'm not going to be able to resolve that because that's an internal Route 53 record. And I'm also not going to be able to get access to this because that's only exists, again, that's a private internal load balancer. It's internal, so it just hangs there. So in order to actually test it, you actually have to be within an instance that's inside the VPC. So that's actually pretty easy to do. We already have instances running in the VPC. They are the spot instances and the auto-scaling instances. So we just grab one of them. Let's grab the development one here. Okay, and then we can use Session Manager because that's all being basically pre-configured and set up. So I'm going to hop into it with Session Manager with my shortcut here. Okay, so it's AWS SSM Start Manager and then targets instance ID, and that's going to get me into the instance. Okay, so that gets me into an instance now. So I'm in the network now. So now these endpoints should work. I should be able to correlate. There's the first one, and here is the second one. So both of them are working. I might as well actually test production also. To test production, it's the same account, so I don't actually even have to switch accounts here. I could have just stayed in there, I guess. Oh no, I actually have to be on production box, right? Because the production VPC is segregated from the development VPC. So let's grab this guy, and then let's check production. So that is good, and I'm just going to show you that I'm not going to be able to hit the other load balancer. So this is the development load balancer. It's not going to, it's not going to work. It's a different VPC. But if I go to production now, go back to CloudFormation, and click on that UFO managed stack, and grab, basically, I'll test both. Grab that production endpoint, that curls just fine, and then grab this production Route 53 record, and that curls just fine. Okay, so let's go back to the README. Let's see. We've basically deployed everything. We've tested everything. Let's go back to the reference architecture and just summarize. So what we did was we deploy a Backend application both on the production VPC as well as the development VPC. Remember, this is all in one single AWS account, so this workflow just works just fine. But we did actually verify that from a instance on the production machine, you can't talk to the load balancer in the development, and vice versa. We just checked from production to development, but both of them kind of work the same there. Okay, and it was just, that the tools will allow you to kind of do both either a single account strategy or multiple account strategy here. But we got a Backend application running in both production and development VPC. Okay, hopefully you found that helpful. Cheers.